Hello guys, welcome back to my YouTube channel. In this video, we will be learning about what a machine learning model is. So basically, a machine learning model is nothing but a mathematical function. It's as simple as that. So you take a mathematical function y is equal to wx, where y is the prediction of that machine learning model, w is the parameter or weight, and x is an input. A mathematical function as simple as this is also a model. But one thing that I would like to mention here is this mathematical function or this model can be more complex than this. Example, it can have many weights, it can have many input parameters, which we will discuss later. So as of now, when someone asks you what a model is, remember that it's just a mathematical function. It can be as simple as y bar is equal to wx. And let us also see what a prediction is. Guys, whatever the output a model gives us for given weight and given input parameter, that is called the prediction. Whenever you create a model, that model is very dumb. It will learn automatically by making mistakes. We will gradually look into the learning process of a model in the upcoming lectures, but this is what it is. Initially, a model is very dumb. It will learn by making a lot of mistakes. As it makes mistakes, it will try to alter its weight so that it can arrive at a prediction that is very close to the expected value. So I have covered that, and that prediction, guys, it can be correct, it can be wrong, or it can be less correct. It can be anything. But if it is wrong, we will make changes to the model. Will learn itself by altering its weights to arrive at a very closer prediction to the expected output. I'll go to the next frame. What a loss function is. Guys, I told you a model actually predicts an output. That output can be wrong as well. So loss function is something that tells us how much wrong the prediction of a model is. So for the model that we have taken, y is equal to wx, the loss function is L is equal to y minus y dash whole square. So y dash is our prediction, y is the expected output, guys. So we are squaring the difference of the expected value and the prediction of the model. That will give us a value called as loss. And why this loss has to be minimized is because only when the loss is less, it means that the model is predicting very close to the expected value, which is a better prediction. So this is very important, guys. Things are getting serious from now on. We will learn what a gradient is. Guys, a gradient is nothing but the derivative of the loss with respect to the parameter or weight. So we know the value of L is y minus y dash whole square from the previous slide. So dl by dw, derivative of loss with respect to weight, is d by dw of y minus y dash whole square, and I'm substituting y dash with wx from the first slide, from this. And this whole value y minus wx, I'm considering it as u. I'm substituting it with u. So it will be, so basically L is equal to u square. In derivatives, there is this concept of chain rule. So d by dw u square will be 2 into u into derivative of u with respect to the weight. So now, guys, you take this u and substitute it with y minus wx as per the previous step, and you also substitute u in the derivative d by derivative of u with respect to dw. This u is also substituted with y minus wx, and y is a constant. So this 2 into y minus wx comes here as it is, and since this is a constant, it will become 0, and derivative of minus wx with respect to w will be minus x, because derivative is taken with respect to w. So the value of gradient is minus 2x by minus wx. So I'll tell, this is where derivatives comes into picture, guys, to calculate gradient. And in the next slide I will tell you why gradient is calculated. So there is this concept called as gradient descent. So this is the algorithm using which a model's new weights are calculated. So I told you earlier that every time a model makes a prediction, we calculate loss, and based on the value of loss, we update the weights to arrive at a new prediction. Don't be confused, guys. In the following slides, I will also explain you how a model training is done. For now, just remember that the value of gradient descent, this algorithm will be new weight, and that new weight is calculated using the old weight minus n into dl by dw. This is actually new. This is called as new. It's called as learning rate or step size. This is the speed at which the model learns, guys. So when you take a model, it goes through a training loop. Basically, the model predicts a value. We calculate if the prediction is right or wrong using laws, and we also compute the gradient, and we use the gradient in this formula of gradient descent to calculate the new weight. So we update the weight, and then we again predict using the new weight. So this cycle repeats, and there are certain conditions after which this this loop would stop. I'll tell you that in the next slide, guys. But before that, remember that dl by derivative of L with respect to W, this gradient was used over here in this algorithm. So like I told you, this training is a loop, guys. It will stop when the loss stops to improve. If there is no significant improvement in the loss, that is when this training loop will stop, or if the gradient becomes very small. Because if this gradient becomes very small, uh, and this new is going to be constant, there would not be much significant difference between new weight and the old weight. So there is no point in calculating all of that again and again. And if they would set, the people who build these models would set the maximum iterations for which they would like the training to run, because training a model is very expensive. The model that we have taken in this example is a very simple model, but these are not production grade models, guys. Standard models are quite heavy. They consume a lot of energy for training. They consume a lot of energy for inference. So when I say inference, after training the model, when these companies deploy those models to be used by public, so this is called as inference. Basically using a trained model, this is called as inference. So that was one condition, maximum iterations. If the maximum iterations are reached, that is when the training loop stops. After that, if the validation loss increases, so basically we would train a model, and that model would give us very less loss when calculated with training data. But if it is given a new data, which is validation data, at that point it might start giving wrong results. So basically what has happened here is the model has performed extremely well with training data, means it has actually memorized the training data, but when it is given something new, it is not able to predict right values for new values. So this is called as overfitting. So basically, if a model aligns very well with the training data, and if it fails to perform properly with what any new data, then that is called as overfitting. And underfitting is the opposite of it. A model performs poorly with training data, but with real world data it performs good. That is called as underfitting. So when it comes to data, there are two types of data, guys. So one is training data, and the other one is validation data. Training data used specifically for training, and validation data, it is not used in training, but it is used to check the model performance after training it with the training data. So that is it. In the next slide, what we will do is we'll take a model, y is equal to wx, this one, and we will try to run this training loop and improve that model. So initially there are certain fixed values, guys. X, which is the input, its value is going to be 1, and initial weight is going to be 0. This is what we will update as the model predicts a value. We'll calculate loss, then we'll calculate gradient. Using the gradient descent algorithm, we will also find the updated parameter. So with the new weight, we will again predict. So y is the expected output, and new is 0.3, which is the learning rate. Usually it is somewhere around 0.1, but to keep the iterations less, I have increased its value to 0.3. So this is, at the end of the day, this is an example, guys. It is only used to give you an understanding of how a model training works. That's it. So now if you see the first iteration, the model is trying to predict a value. Y bar is equal to Wx. I'm substituting W with 0 because that is the initial weight of this model. X is 1. That is the input, and that is going to be constant always. So initial prediction is 0. Now we will calculate the loss. We know the formula for loss is y minus y dash whole square for this particular model. So loss, I'm substituting y and y dash values as 6 and 0 respectively. So value of loss is 36. Now we will calculate the gradient, dl by dw. We have calculated this already in the previous slides. The value of derivative of L with respect to W is minus 2x y minus wx. I'm substituting the respective values. X I'm substituting with 1, y I'm substituting with 6, w is 0. Into x it can be anything, but here in this case it is 1, so that is also becoming 0. So the value of gradient is minus 12. What is the updated parameter? Updated parameter will be calculated using this gradient descent algorithm. We know this formula already. W new is equal to W old minus new into dl by dw. I'm substituting the value of W old, and I'm also substituting the value of learning rate, and I'm substituting the value of dl by dw from the previous step where we calculated the gradient. So after all the calculations, new weight is 3.6. Using this weight, we will go to the next iteration. In the next iteration, we are predicting again. So y dash is equal to wx. The new weight is 3.6. So the value of this prediction is 3.6. I'm calculating the loss. Loss is equal to y minus y dash whole square. For this particular model, I'm substituting the value of y dash and y over here, 6 minus 3.6 whole square. So loss is equal to 2.4 whole square. That turns out to be 5.76. So that is the newly calculated loss, guys. And if you see, after updating the weight, the loss has significantly decreased from 36 to from 36 to 5.76, which is a very significant improvement. And now we will calculate the gradient. We will substitute all the respective values, and the gradient now becomes minus 4.8. We will now substitute the value of gradient and the old weight in the gradient descent formula to calculate new weight, with whose value is 5.04. We will go back to iteration 3. In the iteration 3, same way we will predict using new weight, which is 5.04. The new prediction is 5.04. We are calculating the loss. Loss is 0.9216, which has significantly decreased from the previous loss, and the gradient is minus 1.92. Over here, after substituting all the respective values, we'll calculate the updated weight. Updated weight is 5.616. And the final prediction is what? We are not going to iteration 4, guys. We have already completed 3 iterations. For this particular model, I have set the constraint to stop the training when 3 iterations are complete. So the final prediction would be 5.616. So basically, this is very closer to the expected value, which is 6. So hence, we have learned how to train a model, how a basic model training works. So this is just an example, guys. Y is equal to wx. This model is a very plain, simple model, very plain mathematical function. I have taken this as an example only to help you guys understand how a model training works. This is never as simple as this one. This is only for learning purposes. We will slowly start looking at deeper models in the future videos. But also you have to remember that model training is not done manually. It all happens automatically using certain Python libraries. So I think if you learn basics using a very simple model, that is well and sufficient. And we are at the final slide, guys. The video has come to an end. So if someone asks you what machine learning is, this is the definition, guys. It is the process of adjusting the model parameters or weights to minimize the loss using the gradient descent algorithm. So basically what we did, every time we predicted a value, we calculated the loss, and based on the loss we calculated a new weight using an algorithm called as gradient descent, and we altered the model's parameters. So that's it, guys.